All right, hi everyone. My name is Emma Kubinski, and I will be presenting with Andrew Christensen. We are both students in Fabian Menalled's lab, and we will be discussing a project we completed with the help of Dr. Mac Burgess, looking at the critical period of weed control in organic carrots. So we all know that weeds are a problem in all crops, but they are of special concern within carrots. Carrots are heavily impacted by weeds. A 2017 study looking at over 20 different vegetables found that carrots suffered the most significant yield loss compared to other crops. Um, Due to this, weed management requires very heavy labor demand within carrots. This is especially true for organic farmers who can't rely on chemical inputs. This, coupled with labor shortages in the United States, offers a or creates a significant challenge for weed management within carrots. So, to uh, to beat this challenge, a really important part um, of your weed management is knowing the most efficient and just best time to weed your carrots. So this is where the critical period of weed control comes in. So the critical period of weed control defines the time a crop can persist with weeds without having yield loss. So to dive into this a little more, if your crop grows its whole season and doesn't have any weed competition, you're probably going to have really awesome yields. On the flip side, if your crop is constantly under weed competition pressure, you're probably going to have pretty poor yields. However, between these two extremes, there's a lot of different variations of the length and timing of the competition your crop faces. So, for example, you might let weed persist right when you plant your crop and then control it up until harvest, or maybe you let them persist a little longer. Or perhaps you're on the other end of things and you control weeds up until closer to harvest, or maybe you control them more in the beginning and not as much as the second half of the growing um, cycle of your crop. So, within this, it's important to identify when the best timing is to um, still maintain profitable yields while also maintaining sustainable labor demand to lead to a um, profitable economic return of your carrots. Um, Despite its importance, there's very little information on the critical period of weed control within carrots. There was a study done in 2010 in Canada, but this was carried out in a conventional system, and it only looked at the beginning of the critical period of weed control. So therefore, in other words, it only looked at carrots in the beginning of the growth of the carrot crop. So to fill this knowledge gap, we wanted to um, we wanted to assess the critical period of weed control in organic carrots, specifically within the Great Plains and for growers in Montana, to equip producers with this knowledge to optimize their yield, quality, and economic returns of their carrot crop.
Okay, so our experimental design consisted of two trials, each containing 4 reps that had 8 different treatments each. We used a completely randomized block design where each of the blocks was 2 meters by 1 meter. And in that, each of the reps had 2 different controls, one being weed-free all season and the other being weedy all season. And then under that, we had 3 different treatments that were left weed free up until a certain leaf stage, and 3 different treatments that were left weedy up until a certain leaf stage. As well as these treatments being a way for us to look at the way weed pressure affects carrots, we wanted to see the different amounts of labor input and how they affect carrots. So we were bringing stopwatches out there, and for each of the treatments, we would clock how long it took us to make that area completely weed free. We used little hand tools, scuffle hose, and hand weeding methods. And this allowed us to get the total amount of minutes spent weeding in each plot so we could do an economic cost benefit analysis at the end. So when it came time to harvest, we chose to use random subsamples of 20 carrots for each of the treatment plots to collect our data from. And the data we collected was below ground biomass being the weight in grams, and the above ground biomass being the weight in grams of the leaf. And we wanted to look at not only the below ground weight, but the above ground weight to see where carrots allocate their resources under different amounts of weed pressure. So this picture here in the middle is showing a carrot that experienced weed pressure all season long, and it's really clear to see that all of its resources went to above ground competition to try and battle with those weeds. Another data we got was the sugar content using a Brix refractometer. And the carrots we were growing were orange Hercules carrots, which average Brix rating is 8%, just for reference. And the last piece of data we gathered was the marketability rating, which was a self-made qualitative scale on 1 to 5, where 1 was a carrot that not only had a bunch of twists and kinks and visually was unmarketable, but it was also too small to be used as any sort of processing carrot. And then on the gradient all the way to 5, which would be the perfect, nice, big, round, funnel-shaped carrot that you can sell for the highest amount of money. So here we got all the carrots. We got one. Each carrot is representing a representative sample from each of the treatments. So we have the treatments laid out left to right. And you can really clearly see that those treatments in the middle that had a lot of weed pressure did not produce carrots that you can sell. So starting on the left, we have our season-long weed-free, big, nice, juicy carrot. And then as we start moving to the middle, we're creating that first part of that critical weed-free period where right around weed-free up to leaf stage 4 is when the carrot starts to get below the quality that we're looking for. And then all the way to the middle where that season-long weedy carrot is just completely unsellable. It's barely even there. And then when we climb out on the right here, we're getting weedy for shorter amounts of time. And you can see again how it's really easily correlated with the less amount of time spent weedy, the more carrot you're going to have to sell. So this is just a really visual way to see what that reverse bell shape weed-free, what the reverse bell shape is in the critical weed-free period graph. And here we have the carrot biomass displayed with that picture, so you can see how perfectly correlated they are with that reverse bell shape, and how in the middle there is that critical period for weed control. That same little divot in the middle is shown when we graphed out the different Brix sugar percentages. So like I said, the average is right around 8. Towards the beginning, with the less weed pressure, you're getting averages of around 9. And in the middle, the average was around 5. So that's where we're seeing the value-added processing carrots not really even being a reality. And then here again is the marketability, showing the same reverse bell curve shape, where in the middle there is that critical period to be weeding your carrots. We also calculated a theoretical gross profit by taking that 2x1 meter area that we seeded with 10-inch bed rows and 3-inch seed spacing, and then selling those organic Hercules carrots for $2 a pound. We modeled that out to 1 acre and calculated what the gross profit would be. And again, it really clearly follows that that curve that we're seeing with all the other data. Now, when it comes to looking at the labor input, it wasn't as clearly correlated, and this was just a preliminary study. So we need to look further at how the critical weed-free period for carrots is related to your economic inputs and your economic outputs, and how we can find that perfect balance of the right amount of input and the right amount of output, and also looking at potential value-added products in there. So this project also consisted of field days out at Towne's Harvest Horticulture Farm, which is an educational MSU farm. So we had tours just explaining what we were doing. And this project was also part of upper level weed ecology and management course, where we went out to this experimental plot to explain the concept of critical period of weed-free control using carrots as the example. So looking into the future, we want to expand this project to be located on other farms in the Gallatin Valley. So please let us know if your farm's interested. We want to look at how this critical period for weed-free control can be related to potential value-added products, looking at possibly processing carrots, canning carrots, juicing, different types of value-added juice products. And we also want to expand on evaluating the weed communities and how specific weeds can affect the critical weed-free period in carrots. So thanks so much for listening. See you guys later. Yeah.